I'm going to solve statistics, section 3.1, inshallah, so let's begin. It says Nada has 16 shirts and 9 pairs of pants in her closet. Find the number of ways to choose a shirt and a pair of pants she can wear. You just multiply these two. You do 16 times 9, you get 16 times 9 is equal to 144. So we add this, and we go to question 2. It says, in how many different arrangements are there of the 6 letters of the word modern? There is no repeating letters, so we don't divide by anything. We just do 6 factorial. We should get 720. In how many arrangements are there of the 6 letters of the word modern in which the M and R are together? There is a formula. If these two letters are different and they're together, you should do 2 times, since they can be flipped, times 6, n minus 1 factorial, and 6, n is equal to 6 in this case, so we do 2 times 5 factorial. So 2 times 5 factorial is equal to 240. If it says مثلا in which R and R are together, you shouldn't add 2 times in the beginning, since they're the same letter. They can be flipped, but they're the same entity. How many different arrangements are there of the 6 letters of the word modern in which the M and R have exactly 1 letter between them? There's another formula. If they're 2 different, we do 2 times n minus R, which is the number of letters between them, minus 1 times n minus 2 factorial. Here in this case there is 1 letter between them and we have n to be 6, so we do 2 times 6 minus 1 minus 1 times 6 minus 2 factorial. So we do 2 times 6 minus 1 minus 1 times 6 minus 2 factorial. You should get 192. Derek and Marcel are sitting on a bench with 7 other spare players during the football match. So in total, there's 9 people. What is the number of different arrangements in which Derek and Marcel are not sitting together? We need to find them all together, which is 9 factorial, minus Derek and Marcel sitting together. If they were sitting together, we can use the formula 2 times n minus 1 factorial. 2 times, since Derek and Marcel are 2 different people. So we do 9 factorial, which is the total. So we need to find the complement, minus 2 times n minus 1, which is 8 factorial. You should get 9 factorial minus 2 times 8 factorial. You should get 282240. Now they want what is the number of arrangements in which Derek and Marcel have exactly 1 player sitting between them. You use the same rule as the last question, which is 2 times n minus r minus 1 times n minus 2 factorial. So you replace 2 times 9 minus 1 player, so minus 1 times 9 minus 2 factorial. 9 minus 2 factorial. Okay. And when we put it on the calculator, we should get 2 times 9 minus 1 times 9 minus 2 factorial. 70560. What is the total number of different arrangements of the 9 letters of the word palette? Okay. 2L, so 2L, 2T, 2E. They're repeating. Okay, so they want the total number of arrangements. We do 9 factorial divided by repeating letter 2 factorial 2l times 2 factorial 2t times 2 factorial 2e. So if we put it on the calculator, we should get 9 factorial divided by 2 factorial times 2 factorial times 2 factorial. We should get 45,360. Now they want what is the total number of different arrangements of the 9 letters of the word palette in which the 2 L's are together, the 2 E's are together, and the 2 T's are together. It's hard to apply the rule, so we can draw it out. So 2 L's, 2 E, 2 T, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is one block, 2, 3, 4, 5, 6. So we can do 6 factorial. Since there's no repeating, since they've all been used up, the repeating letters, we don't divide by anything. We should get 720. What is the total number of different arrangements of the 9 letters of the word palette in which the first letter is L, the last letter is L, and the 2 E's are together? We do L, L, E, E, 1, 2, 3, 4, 5, 6, 7, 8, 9. These two are fixed, so 9 becomes 7 factorial. Now we can apply the rule of 2 E's are together here, which is 2, not 2 times, since E and E are the same letter, so we do n minus 1 factorial. So we get 6 factorial. We can divide, since the 2 L's are fixed and we've used up the 2 E's, we still have the 2 T's, so we divide by 2 factorial. We should get 360. What is the total number of different arrangements of the 9 letters of the word palette in which the 2 L's have exactly 3 letters between them? We can use the formula. We don't do 2 times since it's 2 L's, so we do n minus r minus 1 times n minus 2 factorial. N is 9, so we do 9 minus 3 minus 1 times 9 minus 2 factorial. You should get 25200. And now we need to divide by 2 factorial, so for the 2 E's and the 2 T's. So we divide by 2 factorial times 2 factorial. We should get 6,300. In how many different ways can the 10 letters of the word coziness be arranged? 2 Z's, 2 Z, 2 I's, and 2 S's. By the way, these rules cannot be used for permutations, and combination is not included in the final. So we have 6 repeating, so we can do 10 factorial divided by 2 factorial times 2 factorial times 2 factorial. You should get 10 factorial divided by 2 factorial times 2 factorial times 2 factorial. 4, 5, 3, 6, 0, 0. In how many different ways can the 10 letters of the word coziness be arranged such that the 2 Z's are together and the 2 S's are not together? So we can find the 2 Z's and the 2 S's are together and the 2 Z's are together alone and then minus them. So we can find 2 Z's are together. So we have ZZ, 1, 2, 3. Well, no need. We can just apply the formula for 2 Z's are together. We don't do 2 times. So we do n, which is 10 minus 1 factorial, which is 9 factorial. We get a number, but then we have 2 repeating i's and 2 repeating s's. So we need to take the answer and divide by 2 factorial times 2 factorial. You should get 90720. Now we can find 2 z's are together and 2 o's and 2 s's are together. So we can do z, z, s, s. It's hard to apply the formula when you have more than like 2 letters together. So we can just draw it out. So we have 2 z's, 2 s's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 factorial, okay? You have the 2 z's and the 2 s's, but we still have the 2 i's. So we do 8 factorial divided by 2 factorial. You should get 20160, and then you do this one minus the answer that you got on the calculator. You should get 70560. And how many different ways can the 10 letters of the word coziness be arranged such that Z-I-N appear together in this order? So we have Z-I-N as one block. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 1, 2, 3, 4, 5, 6, 7, 8. 8 factorial. We have the I, so we have one more I, so we don't include it. N is not even repeated, and Z, we only have the 2 s's, so we do divided by 2 factorial. So we have 8 factorial divided by 2 factorial. You should get 20160. What is the total number of arrangements of the 10 letters of the word salamander? There's 3 A's, 3 repeating A's. That's it. So we can do 10 factorial divided by 3 factorial. Since the 3 A's are repeated, you get 604,800. What is the total number of different arrangements of the 10 letters in which the 3 A's are together? Since the 3 A's are the same, we don't multiply by anything in the beginning. We should get 10 minus 3, the 3 A's minus 1, times 10 minus 2 factorial. So we do 10 minus 3 minus 1, okay, times 10 minus 2 factorial. You should get, oh my bad, this the 3 A's are together, but there's nothing between them. So you can just draw it out. A, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2, 3, 4, 5, 6, 7, 8, which is 8 factorial. You get 40320. Or you can do n minus 2 factorial. Since it's 3 A's, if it was 2 A's, you do n minus 1 factorial. But since it's 3 A's, you do n minus 2 factorial. You do n minus 2 factorial, which is 8 factorial, you get the same thing. Also, wait, if you go to the explanation, in case 3, where is case 3? This is case 1, case 2, case 3, no, case 2 actually. See, it says it's not always multiplied by 2. If it's 3 items, it's multiplied by 3 factorial. 3 items appear together in any order, so it's 3 factorial. مثلا, if that question was A, R, and B are together, you multiply by 3 factorial in the beginning. Okay. So we have S and R have exactly 3 letters between them. So we do 2 times, okay? 10 minus 3 minus 1 times 10 minus 2 factorial outside, divided by 3 factorial for the 3 repeating A's. So we do 2 times 10 minus 3 minus 1 times 10 minus 2 factorial divided by 3 factorial. You should get 80640. And how many different ways can the 11 letters in the word Mississippi be arranged? There's 4 repeating I's, so we have 4 I's, and we have 4 S's, and we have 2 P's. So we can do 11 factorial divided by 4 factorial times 4 factorial times 2 factorial. We should get 34650. Okay, bismillah, inshallah it's all correct. Okay, alhamdulillah.